Hello, welcome back. This is chapter 5.5. Again, part 2. And this part is not going to be on standard form, but it's going to be on the second part of the chapter, point-slope form. Point-slope form, well, we've learned about slope-intercept form, we've learned about standard form, now we're learning about point-slope form. And point-slope form is actually under that same linear equation umbrella. The umbrella that I've been drawing for the past 2 lectures. You have your y equals mx plus b. You have your ax plus by equals c. And now we have one last one, which the form of it is written this way. Y minus y1 equals m times x minus x1. All right, so what I first want to discuss is the general purpose of each of these. These two, we learned them by their general purpose. This one, we won't learn about it, and we won't use it for its actual intended purpose. We're going to use it for a different reason. And so I'll teach you that. But first, I want to mention a quick note about each of their purposes. So on your notes, you have the 3x3 box with slope-intercept, standard, and point-slope form. And then in the empty rectangles to the right side, you can write this stuff. So y equals mx plus b. The point of this is to find the slope and the y-intercept. That is the point of it. You find your m and your b, and that is the slope and the y-intercept. When you put it in this form, those two things are obvious. You can see them within the equation. That is its purpose. The next one, standard form, the point of it is to make it very easy to figure out your y-intercept and your x-intercept. And so, whereas this one, you find one point, the y-intercept, and then you find the slope of the line. In this one, you're finding 2 points of the line. And so with both of these equations, you're given a point in the slope or 2 points, which you can use to graph the linear function. You use to graph the line. This third one, you can also use it to graph the line. And here's the general idea. This is the one that you can write down. The purpose of the point-slope form, this last one, is to see how the graph is translated, so how it moves up, down, and turns from the very, very general function y equals x. Y equals x. If you were to graph this very general function y equals x, you would have a graph that looks like this. It'd have a slope of positive 1. It would cut exactly diagonal, splitting this graph in half. And this is what we call a parent function. And this equation, what it does is when you put it into this form, you take this parent equation and you move it around according to how m, x1, and y1 change. This isn't something that I don't think that you deal with it at all this year, but in later math classes throughout high school, you'll be dealing with translations like this, which is the purpose for your point-slope form. All right, now we're going to talk about our use for the point-slope form. We're using it to achieve a different goal. In 2 lessons ago, we talked about ways to find an equation from 2 points. And we had a chart that said, let's see here, gather your information. And so if there were 2 points, you would write out what those 2 points were. You would have x1, y1, x2, y2. Those are your 2 points, and you'd usually put numbers into those, so you'd work it as if it were an example. And then the second step was use these to find a slope. So this is your first step. Your second step is to use those to find the slope, which is your m equals y2 minus y1 over top of x2 minus x1. All right, our third step was to, in the previous notes, was to take your slope and then one of these coordinate pairs to plug them into y, m, and x, and that's the way you find b. The point-slope form, we can use the point-slope form equation as another way to find b. So here is the alternative second step for finding b from 2 notes ago. So this step is to use your point-slope form, and if you read the italicized words in the thought cloud, you'll be able to hopefully figure out what it is. But and in this case, what you do is you take y, and then you would leave y just as a variable. You'd subtract y1 from it. You would put that equal to m, so your slope times x, which is a variable, you aren't substituting anything in there, minus x1. And once you plug in a number for y1, m, and x1, then you would simplify the equation. And when you simplify it, you would get your slope-intercept form, y equals mx plus b, which not only tells you b, but it also just gives you the full equation. And that's one of the strengths of using this way of finding b in your third step. All right, so now for the example that I have written there, I'm going to go through this and I'm going to substitute numbers in for your x1, y1, x2, y2. And the numbers that I gave were 3 and 11, and then 7 and 19. So you got 3, 11, 7, and 19. Over here, finding the slope, you'd substitute y1, y2, x2, and x1. And you would have 19 minus 11 over top of 7 minus 3. And that gives you your slope. Now down here, we have our point-slope form written out. So now we substitute for I have to simplify this. This is going to equal 19 minus 11. You're going to have 8 over top of 4, which equals 2. So 2 is our m value. So we substitute 2 in here. And then we want our y1 and our x1. And in this case, our y1 is 11. Our x1 is 3. Now we simplify. And there's one important thing you need to notice. This 2, the slope, has to distribute to x and negative 3. So we're going to distribute here. And that is going to equal, that's going to go to y minus 11 equals 2x minus 6. Now our goal is to make it look like y equals mx plus b. And so we got to get this negative 11 out of the way so that it's just y on this side. Add 11 to both sides. And that will bring us to our final form of y equals 2x plus 5. There is your equation. You have successfully taken these 2 points and turned them into an equation by finding the slope and then using your point slope form to find the equation.